right, hey guys, we are on to our next lesson here. We're in day 6, solving equations and inequality notes. So as you notice, this is actually a worksheet. Again, it follows the same structure as always. Pause and try on your own and use me as an extra resource. So let's make that a little bit clearer if I can. Yeah. So there's no objective because it's just kind of a continuing practice of what we've already been doing with solving equations and inequalities. So today is pretty much just going through and attempting some problems, reasoning through some problems in different categories with equations and inequalities. All right, so we're just going to jump right into it. Again, you should be attempting these first. So it says 2m, let's do it in red. That's my favorite. Red. Perfect. It says 2m plus negative 15. Again, I mean, if plus a negative, I'd write that as minus 15. Plus a negative is just the same thing as minus. And then for the other side, we got 3 times 2m plus 7. We can distribute the 3 through. And we're multiplying, so 3 times 2 is 6. So 6m. And 3 times 7 is 21. So we got 21. All right, then when we get this set up, a very common setup here. All right, we got that on the left and that on the right. So we're going to move things around and combine like terms. So I usually try to start with a variable, and I try to start with the smaller of the two. So like I'm going to take the 2m, and I'm going to move it to the other side. So 2m on the other side. So we subtracted those out. That goes away. 6m minus 2m is 4m. And then I'm going to subtract the 21 on this side, so it goes away. And I'm going to subtract the 21 on this side. So use your calculator or try to do it by hand, but negative 15 minus 21, that's like saying plus negative. And negative 15 and negative 21 gives us, I'm going to write this out, negative 36. Divide both sides by 4. That's the last step. Since it's 4 times m, we're going to divide by 4. And negative 36 divided by 4 is negative 9. And that's our answer. All right. Again, pause video. Try the next one on your own. I'm going to kind of run through this one kind of quick. But again, we're trying to get it to look like this step right here. We're trying to simplify everything out. Distributing the 3. Distributing the 4. So I'm going to say this is 18n, oops, sorry, not m, n, minus 6, and remember, plus a negative is the same thing as minus 146 is equal to 28n plus 8, distributing everything out, okay? So we can keep going. 18n on this side, we have 2 numbers we can combine together. Negative 6 and negative 146 is negative 152. And then we're at the step where we can start moving things to the other side, right? So like I said, I'm going to take the lower of the 2 numbers. I'm going to say minus 18n on both sides, minus 18n on both sides, and I get 10n. I can minus 8, and I can minus 8. Remember, minus you can say is the same thing as plus negative. So negative 152 and negative 8 is negative 160. And then we can divide both sides by 10. So that is negative 16 equals n for my final answer. Very cool. All right, equations in context. So directions: write and solve the equations in each word problem below. Then answer any additional questions provided. So it's equations again, but now we have some context behind them. So we have like a word problem. It says Mary scored a 51, a 40, 89, 97, and 77, and an 88 on her first 6 quizzes. What does she need to score on her next quiz for her average to be 76? All right, this is a very common question in on a exam, you can even see at the bottom right here, it says this is adapted from a released EOC. This is a very common question. Remember how to find average. Average value is when you just add all the numbers up and divide by how many you have. Okay, so we have 6 quizzes, and it wants to know what we're going to have to score on the next quiz. So that's our 7th quiz for her to average 76. So the formula is adding everything up and dividing by the number of values. So we got 51, we got 40, we got 89, we got 97, we got 77, we got 88. And that's the first 6 quizzes. And what we're looking for, the value that we're looking for, is the value of the 7th quiz, which we're going to call X. So here I want these 7 scores, all divided by 7. I want those to equal 76. Ooh, that's bad. 76. Okay. So, in order to do this, it's pretty straightforward. We want to get X by itself. It's all about getting X by itself. So what I can do is I can simplify all that down, which when I did it in my calculator, I got is 442 plus X divided by 7 equals 76. And then it's all about getting X by itself. So I'd multiply both sides by 7 to get rid of the denominator. And I'm getting 442 plus X equals, I'm getting 532 for this value. And then since we're plussing, we're going to subtract it. So I'm going to subtract 442 from both sides. Those go away. And I'm left with X equals 90. So test your answer if you get it. Like, it's saying that you have to get a 90 to get an average of 76. So if I add up all 7 numbers and divide by 7, I should get an average of 76. Okay? Alrighty, number 2. Adam has been offered a job as a waiter. He makes $12.50 per day, plus $8.25. Whoops. I didn't do that. Anyway, Adam has been offered a job as a waiter. He makes $12.50 per day plus $8.25 per hour in tips. Create equations and solve them to answer the following questions. It says, how many hours will he have to work in order to make $100? And I'm going to clarify, that's supposed to say how many hours in a day will he have to work to make $100. Okay? So, I know that I get $8.25 per hour in tips. So I'm going to put per hour, just putting the H beside it for multiplying. And then I get a base value of $12.50 per day. Okay. Now collectively, the tips plus the $12.50, that's going to equal $100. I want to know what value is going to make that true. Okay. So again, we should be able to solve these, but that's what this all day is about, is learning how to do these. So I would subtract $12.50 from both sides. So running out of space, I'm going to write it right here. So I'm left with 825H is equal to, that's going to be 87.50. And then we can divide both sides by 825. So I'm getting that H equals, in my calculator, I'm getting 10.6. So what that means in the context of this problem is that I have to work a 10-hour, almost an 11-hour day, really, 10.6-hour day in order to make $100, which means this job kind of sucks. Don't do this job. All right, B, how much will he earn if he works 7 hours? Well, again, in this case, I like this because 7 hours, well, I know he works $8.25 per hour. So we're literally plugging in 7 for H plus the $12.50. And really, I'm not solving for anything but what that equals. So I'm typing that in the calculator just like I see it, and I'm getting $70.25. And hopefully that makes sense because 10 hours gives you $100. So 7 hours should give you something less than that, which is $7.25. All right. Very good. All right, moving on to literal equations. Let's discuss what literal equations are. So a literal equation is an equation with one variable. That's supposed to be an O. One variable where every variable has an important characteristic. All right. So to solve a literal equation, use the same steps as moving variables in algebraic equations with one variable. You'll end up with an equation with all variables remaining. There might be some numbers. But what that first checkpoint's really saying is a literal equation is an equation with one or more or with more than one variable where every variable has an important characteristic. So you're going to have a bunch of variables, and when you're asked to solve for a specific variable, you just leave that as a variable. So like let's do an example. It says simplify the following equations for specified variables. Like this right here, number 1, is a literal equation. It has more than 2 variables. It's c, pi, r. So we have no values for those, but just what they are. And it wants us to solve for the r value. So literally it means to get r by itself. We have c equals 2 times pi times r. So how do I get rid of r? Well, if I'm multiplying by 2 and pi, I'm going to divide both sides by 2 and pi. So those go bye-bye. So whatever I do on the right side, I would do on the left side. So r equals c over 2n. And that's my answer. Or not n, I'm sorry, pi. I always write pi's as n for some reason. I don't know why. There you go. And that's a c. I like literal equations because you're just getting variables by itself. That's it. So here we have k times e equals 1/2 times m times v squared, and we're solving for m. Okay. Well, it's the same thing as before. Okay. We're doing 1/2 times by m times by v squared. So since I'm multiplying by those values, I want to divide by 1/2 and v squared. Okay. So then the 1/2s cancel and the v squared cancel, and I'm left with just m. But whatever I do on the right side, I'm going to do on the other side. So I'm going to divide by 1/2 and v squared. The only thing is we don't like to leave fractions under fractions. So remember what happens when you divide by a fraction. It's like doing same change flip. Okay. So really that 1/2 changes to 2 over 1, which really is going to be 2 ke over v squared. Another way we could have done that if you don't like dividing by a half is you could have done this. You could have said, all right, we got ke equals 1/2 mv squared. You could have multiplied both sides by 2, and that would have gotten rid of the half. So then you would have had 2 ke equals mv squared, and then you could have divided both sides by v squared. And that might have been a way you would have liked it better. Either way is fine with me. All right. Very cool, very cool, very cool. All right, so that's equations. Let's do some inequality review. Yay, inequalities. Directions: solve the following inequalities, and then graph the solutions on the provided number line, then explain what the solution means. All right, we're just going to verbally explain that, but let's solve it. So it's solved the same way as an equation. Just leave that greater than symbol right here, number 1, just like that. The only time the sign is affected, let me emphasize this. Let's do this right here. The only time that the sign changes, like or flips or messes with, is if you divide from one side to the other with a negative number, or multiply from one side to the other with a negative number. Very important. All right. So, let's do it. All right, I'm going to distribute the 9. So I got 18x plus 9 is greater than 5x plus 1. Again, just solve it the same way that we did the warm-up. 18 minus 5 is 13x. I'm going to subtract both sides by 9. I'm going to just bring that greater than symbol right on down. And then 1 minus 9 is negative 8. So dividing both sides by 13, again, I've not divided or multiplied by anything negative, so the greater than symbol remains just that. And negative 8 divided by 13, you can leave as a fraction for your final answer, but to graph it, it's probably easier to see it as a decimal. I'm getting negative 0.62. Which, like, if I make this 0, 1, 2, 3, and negative 1, negative 2, negative 3. I would probably put, so negative 0.62 is like right here in between 0 and negative 1. I'd put it right here. And I'd put it as a open circle. And since x is greater than that, I'm going to go this way. Okay. Very cool. All right, the next one. I'm going to divide both sides, or I'm going to distribute the 10. So I get 10x minus 20 is less than or equal to 16x plus 17. Again, solve the same way I've been doing. Subtract 10x, subtract 10x. I get 6x. Subtract 17, subtract 17. Plus negative. I'm getting negative 37. All right, I'm still dividing by a positive number, not dividing by a negative number. Oh, I put 36. Sorry. Should be negative 37. Divide by 6. And then that means that, so negative 37 over 6 is a fine answer, but for our purposes, that ends up being negative 6.17. And again, I like to flip that around, just completely mirror that to graph it. So really, this is the same thing as saying x on the left, flip that sign, negative 6.17. Which again, maybe I'll put like, I don't know, negative 7, negative 6, negative 5, negative 4, negative 3. All right. So negative 6.7 is like right here, and that's going to be a closed circle because it's or equal to. And since I'm greater than, I go that way. Cool. Very nice, guys. Good job. Just a little bit more. One more page. All right. Proving points. This one's pretty straightforward. It's not terrible with inequalities. It says directions. Determine if the values are a solution to the equation or inequality provided. If none are, explain why. And again, we'll verbally explain. You can write down as you need to. But for the first problem, it's an equation. And it wants to know, do any of these values, so it wants us to test these and see if they actually work. So the first one is negative 1, 6, 0, 1/2, negative 1. Now, I'm going to save us some time. If there's an equal symbol, there's only an exact number of values that can work. And I'll go ahead and spoil it for you. If it's a line, like these are linear equations, so like not squared or cubed or anything, there's only going to be one answer. So I know that at least 3 of those, maybe even 4 of those possible solutions aren't going to work. So why don't we just solve for it? Save ourselves the steps. Okay, because this is what I'm going to do. Because it said determine if the values are a solution. So I'm going to distribute the 3. So that's negative 12x minus 3 equals 6x. I'm going to add 12x to both sides, plus 12x to both sides, and I get 18x equals negative 3. And then I'm going to divide both sides by 18. And I get x is equal to whatever negative 3 over 18 is. Again, that's a fraction that can reduce down to negative 1/6. So in this particular equation with an equal sign, we only have one value that could possibly work, negative 1/6. So the question is asking us to determine if any of those values work. Well, only x equals negative 1/6. The rest do not equal. And that's because it's only the solution for it is negative 1/6. I mean, you can test it, plug 0 into that. You're not going to get the same answer. Okay? Now, I'm almost inclined. So that's the same thing for number 2. Like for number 2, you could also test any of those points. Like I can plug 0 in and test. Like, just to show you, I can plug 0 in for, like, if I want to test 0, for instance, I can plug 0 in and see if this statement is true. 0 minus 1 is negative 1, and negative 1 times 6 is negative 6. 0 times 2 is 0, minus 1 is negative 1. Negative 1 times 3 is negative 3. So is that true? Is negative 3, negative 6, is it greater than negative 3? Well, no, it's not. So I know that that 0 is not an option. Or I could do it this way. I could solve this inequality, right? I could say that I can distribute the 6. Oops. And then as greater than, I can distribute the 3. And then I get minus 6x minus 6x. I get negative 6 is greater than negative 3. Oh, so that's interesting. So because the x's cancel out, I pretty much just proven that since this statement's not true, it doesn't matter what value I plug in for x, the x's will always cancel. So none of the values work. Test them. But no matter what, whether I just leave it as x or plug in a number, it's always going to come out to the same thing, that negative 6 is greater than negative 3, which isn't true. So the answer is none to that one. Yeah, pretty cool. All right, last problem. Inequalities in context. We did equations in context. Let's do inequalities in context. It says directions. Write and solve the inequalities in each word problem below. Then answer any additional questions provided. So number 1. A shipping container will be used to transport several crates of non-perishable food across the country by rail weighing 150 kilograms each. The greatest weight that can be loaded in the container is this. Other shipments weighing this kilograms have already been loaded into the container. Write and solve an inequality that can be used to determine C, the greatest number of 150 kilogram carts, so the number of carts is C, that can be loaded into the shipping container. Okay. Well, I know that initially speaking, I have 3,120 kilograms. And I know that every cart from that point forward has 150 kilograms in it for every cart C. So this is from my carts. This is what initially is in there. And I know that at most, so greater than or equal to, less than or equal to, the most that it could possibly be is 41,525. So I know at the very most, that's what it's going to be. Okay? All right. Let's keep going. So I'm going to subtract 3120 from both sides. And I get 150c is less than or equal to. When I subtract that, I am getting... What am I getting? 38,405. And then I can divide both sides by 150. And I'm getting that C, my value C, has to be less than or equal to 256.03. That's the amount of carts that I can have, or the number of crates, the number of crates that I can have to be loaded into the shipping container. So since you can't have a decimal of a crate, the most you can have is 256. It's got to be less than or equal to 256. All right. B says, what does the solution mean in the context of the problem? Does it make sense and why? Oh, yeah, well, there you go. It means that if I have 256 crates, again, you can't have 0.03, but if I have less than or 256 crates, I'm going to have no more than 41,525 kilograms, the max weight that this container can hold. Okay, so as long as I have 256 crates or less, I am within that range. All right. Now, how do you graph it? Well, I'm just going to kind of pick some numbers here. Here's 256. I'll put in the middle. Maybe I can go up to like 260, go up to like 265. I can go the other way. I can go like 250, 245, something like that. And I know right here at 256.03, which is like right here on 256, basically, I know it's going to be a closed circle because it's or equal to. And I know that C can be any value less than that. Okay? There you go. That's it. So today was, again, just practicing solving equations and inequalities, doing the mathematical procedures behind it, and then just knowing how to interpret it and understand it in the context of the problem. So writing the equations, solving the equations, all the things. All right, well, that's all I got. Thank you, guys. Hope you have a fantastic day. Good luck.